Hi everyone, this is a great try on your own example. So we've talked through all this new or not new vocab about functions, increasing, decreasing, concave up, concave down, local max, local min, inflection point. And this doesn't necessarily use that wording, but it's looking at those things. So you've got three different graphs, and then there are just a bunch of different things at the bottom that you're supposed to look at and decide if they're positive, negative, or zero. So again, my advice is pause and try and run through these, and then you can just click to the end and check your answers and rewind if you need to get any feedback about any of those. Okay, so the first three are all about function f. So we're given x value 1 in all three of these. So if I look at function f and I use x value 1, I'm talking about this point right here. And I'm supposed to decide whether I think f of 1 is positive, negative, 0, and then the same for f prime and f double prime. So this one's really about, do you know how to, what each of these things are on a graph. So f of 1 is your y value, right? If it's the function, it's y value, which is definitely positive. F prime of 1 is the slope of your tangent line, which is also positive. And f double prime of 1 is your concavity. Since we already have a tangent line approximately sketched in, we can see that this is bending down below our tangent line. So that's concave down. Okay, so there's the first one. The second one is also about f, but now we're supposed to look at f prime of 2, f of 2, and f double prime of 2. Okay, so f prime of 2, that's a slope. F prime is slope, so that appears to be a negative slope. F of 2 is a y value, which appears to be positive. And f double prime of 2 is concavity. Once again, we're below the tangent line. Slopes are getting more negative, smaller, so that's negative concave down. Okay, f of 5. Okay, so 5 right here. So we're looking at that point. F prime of 5 is our slope, which appears to be positive. F double prime is our concavity. This is bending up above the tangent line, so that looks positive. And then f of 5 is our y value, which is negative in this one. Okay, so there's several points on f, which is the most interesting graph, but actually what I find is that a lot of times people get messed up by the simpler graphs. So I think that we would look at G and H and go, oh, those should be easy, but they sometimes really mess with people. Okay, so for G, we're just supposed to look at this point right here, and we are supposed to say whether we think G double prime is positive, negative, 0, so that's concavity. This is a linear function. It does not have any bend, so that's a 0. G of 2 also looks like it's 0. That's our y value, so that's another 0. G prime of 2, that's slope, which is definitely negative. So the zeros sometimes mess people up a little bit. Okay, and then for function h, we're also supposed to use x value 2, so we're talking about that point. Slope at that point is 0. That's horizontal. The second derivative at that point, concavity, there's no bend, so also 0. And then y value at that point is negative. Okay, so that's that one. Let me just point out that you didn't get asked, because it's sometimes a little hard to estimate, but this one would have f prime would be 0 at the local max and local min, and f double prime would be 0 at the inflection points. So those are sort of approximate, but it looks like they're near the x-intercepts. All right, thanks for watching.